Okay, today we're going to be going over section 10-2 and we're talking about operations with radical expressions. Okay, main thing you need to know from this section is that radical expressions are like terms whenever they have the same radicand. Okay, so if you were asked to simplify and identify the like terms between A, B, and C, you would start off just like we did in the previous lesson by getting the prime factorization of the numbers. So you have 75, and we're going to break that up. We know that that's 3 times 25, and 25 can be broken out to 5 times 5. Okay, so what we have here is the radicand is equal to 3 times 5 times 5. Okay, you have your pair, kill one off, set one free, so you'll have 5 radical 3. Okay, let's simplify radical 45. Again, I'm going to find the prime factorization. This is 5 times 9, and 9 can be broken out as 3 times 3. Okay, so radical 45 is the same as 5 times 3 times 3. We have our pair, get one off, set one free. So you'll have on the outside 3 and 5 underneath the radical sign. Okay. One last one, we're going to simplify radical 80. And let's see, let's divide in 2 again and again and again. Okay, so looks like the value of radical 80 is the same as radical 2 times 2, 2 times 2 times 2 times 2, 2 times 2 times 5. Okay, so let's look for pairs. We have, looks like 2 pairs of 2's. Here's one, here's another. Get one off, set the others free. So you'll have on the outside 2 times 2 times a radical 5. Okay, and 2 times 2 is 4 radical 5. Okay, so we simplified all three, A, B, and C, and now we need to identify the like terms. Okay, going back to the definition, like terms have the same radicand. Okay, so let's look at the radicands. You have 3, 5, and 5. Did you see the same radicands? That's right. You have the same radicands in B as you do in C. So these are your like terms. Okay, so you can identify those as like terms. Okay, and I'd like for you to try your own example between A, B, and C. Given, please simplify and identify which ones are like terms. Okay. The significance of identifying whether radicands are or radical expressions are like terms is that you can operate on them, meaning you can add or subtract if they are like terms. Okay, so we're going to use that general idea to take a look at this problem here. Remember, we can add only and subtract only if they are like terms. So we had simplified radical 45 earlier, and we said that radical of 45 is equal to 3 radical 5. Okay, we also simplified radical 80 to be 4 radical 5. Since they are like terms, we can combine them together. We can add, we can subtract. Okay, and the way it goes is they're like terms. You would treat it just like you would a denominator. It stays the same. Okay, so when we combine, you're combining the outside values. So this will be 7 radical 5. Okay, so your radicands stay the same. You just add or subtract the numbers on the outside. Okay, so let's try example number 2. Okay, we said earlier that radical 75 is equivalent to 5 times radical 3. And we said that radical 80 is equivalent to 4 radical 5. Can we subtract these? Okay, if you said no, you're absolutely correct. And the reason for that is that the radicands are not the same. These are not like terms. When you have terms that are not the same, you cannot combine them. So you can't add, you can't subtract. We can't really do anything to simplify this any further, so this would be your final answer. Okay. Why don't you try this problem here? Okay. When you're multiplying radicals, you have a number of different cases you may encounter. Okay, first case is what appears to be very similar to multiplying a monomial by a monomial. Okay, you're going to be multiplying outside with outside, the inside with the inside. Okay, what I mean by this is, let's take a look at this example. Outside we have 2 and 7, so we're going to multiply the 2 times the 7 together. Inside, meaning inside underneath the radical sign, we will multiply together 15 and 5. Okay? And of course, we're always looking for pairs of prime factors. So we know that 15 is the same as 3 times 5. Okay? What this does is gives us our pairs. Okay? So we're going to cross one out, set the other free. When you set the other free, what happens is it comes outside and it will also be multiplied to everything outside. What remains is 3. So we have 70, right? 14 times 5, 70 times root 3, or radical 3. Okay. Another case you may encounter is when you have something that looks like a monomial times a polynomial. In this case, it's a binomial. Okay, and it will prompt you to distribute. Okay, we're still multiplying, but this will tell you to distribute. You need to multiply to each term inside that set of parentheses. So the very first item is 6 times the radical 3. You're going to add that to 6 times 5 radical 2. Okay, well, 6 times radical 3 is just 6 radical 3. And you're adding it, so to 6 times 5 radical 2. Remember, outside with outside, inside with inside. So outsides, 6 times 5 gives you 30 and radical 2. Okay, again, we would like to combine them if we could. However, these are not the same, so they're not like terms. We cannot combine them, so we are done. Okay. Now the last case that you may see is a case where it looks like a binomial times a binomial. And just like we did in the previous section, we're going to be FOILing. Okay, so make sure that you keep everything very neat. And I always like it. I'm going to write out FOIL. Okay, and just so we can break this out, first we have 5 radical 2 times 2 radical 10. Okay, for the first terms, that's right here. Okay, the outside terms are these two right here. So we have 5 radical 2 times, and that's a negative 3. Remember, the sign is in the front of that value. Insides, we have these two, 3 radical 5 times 2 radical 10. And the last terms, okay, 3 radical 5 times a negative 3. Okay, let's go ahead and simplify this. Remember, when we're multiplying, I have to go back to my case number 1. Okay, remind yourself about what happens when you're multiplying what looks like a monomial by a monomial. It's outside, outside, inside, inside. Okay, so let's multiply together. Outsides, 5 times 2. And insides, 2 times 10. Okay, that gives me 10 radical 20. Okay, here we have outside, outside, negative 15 radical 2. Here we have outside, 6 radical Actually, it might be a good idea if I kept it written out. Okay, outside -9 radical 5. Okay, I actually said it was a good idea for me to keep it written out, and let me tell you why. You see here that I wrote 20, but I know that now I'm going to have to break it out again. So what I could have done is instead of written 20, I could have kept 2, and I could have break out the 10 to 2 times 5. Okay, all of this is underneath the radical sign. Okay, you are looking for, of course, our pairs. Cross one out, bring the other out, and it's going to be multiplied. So that'll be 20 radical 5. Okay, here we're going to subtract 15 radical 2. This is 5 times 2. Those 5s will be a pair, freeing this 5, so that'll be plus 30 radical 2. And I can't do anything with this. Okay, now let's identify our like terms and see what we can combine. Okay, so looks like we have these two are radical 5s. Let's combine these. Okay, we have 20 and -9, which leaves us with 11 radical 5. Remember, the sign stays the same, not the sign, but the radicand stays the same. Okay, they act just like denominators. They do not change when you add them. Okay, and we have here these two we can combine, and that'll be a positive 15 radical 2. Okay, these two are not the same, so we can stop here. Okay. Why don't you try these 3 problems in your textbook, bring it back tomorrow, and we will talk about the problems in class. Thank you.